Next, we go with question number 8. A quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. The figure is given in your question. So here you have a quadrilateral is drawn to circumscribe. Circumscribe means the sides of the quadrilateral are tangents for this circle. That means the sides of the quadrilateral touches the circle at one point each. Now you are going to prove that AB plus CD equal to AD plus BC. Students, here you can see 4 points on the circle and 4 points outside the circle. Which are the points on the circle? There are P, Q, R, S, and the points outside the circle is A, B, C, D. And when you learnt theorem 10.2, you learnt that the tangents to a circle from an external point are equal. The length of the tangents from an external point to the circle are equal. Isn't it? That was your theorem 10.2. You are going to use the same concept here to prove this. We know that D is a point outside the circle. So I can say that dr is equal to ds. AS is equal to AP. CR is equal to CQ. BQ is equal to AP. Using which theorem? Theorem 10.2. Now, from this figure, we can conclude a few points which are dr is equal to ds, BP equal to BQ, AP equal to AS, CR equal to CQ. Why? We are using the theorem 10.2. The length of the tangents to the circle from an external point are equal in length. Now, adding the LHS and RHS of the above equation, we get dr plus BP plus AP plus CR is equal to ds plus BQ plus AS plus CQ. Okay. Rearranging dr and CR, BP and AP. When you are writing this rearrangement, you will find that you have taken the points in such a way that R terms come on LHS side, P terms come in LHS side, and S in RHS and Q terms in RHS. Rearranging, we get dr plus CR plus BP plus AP. Why are you rearranging like that? Let's see. dr plus CR. What is dr plus CR? dr plus CR. That is DC. Now, what is BP plus AP? BP plus AP. That is BA. So, CD plus AB is equal to BC plus AD. That is what you have to prove here. Hence, proved. Clear? Using the same concept, you have one more question in this exercise. So, we'll discuss that also. That is, prove that the parallelogram circumscribing a circle is a rhombus. In the previous question, it was a quadrilateral. In this question, it is a parallelogram. What is the peculiarity of a parallelogram other than quadrilateral? Quadrilateral and a parallelogram are a four-sided polygon. Then what makes quadrilateral and parallelogram different? In a parallelogram, the opposite sides are equal. Now, what is the difference between parallelogram and a rhombus? In a parallelogram, opposite sides are equal, but in a rhombus, all the sides are equal. Clear? So, using the same concepts which you used in the previous one, that is the length of the tangent from an external point to the circle are equal, we prove this also. That is, here from the figure, we prove that dr is equal to ds, bp is equal to bq, cr is equal to cq, ap equal to as. Why? Using theorem 10.2. Adding all these we get dr plus bp plus cr plus ap equal to ds plus bq plus cq plus as. Now rearranging, we'll get ab plus cd is equal to bc plus ad. Okay, now we are taking the peculiarity of a parallelogram. What is the property of parallelogram? Opposite sides are equal. That is, AB is equal to CD and BC is equal to AD. That is the property of a parallelogram. Since in the question it is given that ABCD is a parallelogram, we can use AB is equal to CD and BC is equal to AD. Now what happened? 2AB, because why? CD I can write it as AB. AB plus AB, 2AB, BC plus BC, 2BC. So AB is equal to BC. AB is equal to BC, BC is equal to AD, and all the four sides are equal. All the four sides are equal. So, this parallelogram can be described as a rhombus. In the initial point, I have told you that the difference between a parallelogram and a rhombus is that, what is that? In a parallelogram, opposite sides are equal. In a rhombus, all sides are equal. By this, we end today's session. Thank you. Have a nice day.